Okay, so hey everybody, I'm Jeff, and I'm going to be streaming some Go development, a little bit of DevOps. We're going to build something pretty much from scratch. We're going to, well, the idea is JQ as a service over SSH. So JQ, if you haven't used this tool, it's sort of one of the most popular command line tools for working with JSON data. So for example, we have my GitHub profile, and working with this on the command line, if you want to get some field or something, it's kind of obnoxious. You might go for some crazy sed or awk thing, or maybe grep, but instead you can use JQ and do various selections, so grabbing name, You can also construct other JSON objects. You can get the raw value, which is useful when you're actually doing command line bash scripts and stuff like that. So this is a great tool, but you have to install it, and maybe you're on a server somewhere and you're trying to work with JSON or on a computer that doesn't have it, and I'm sure you could probably do brew install JQ or go to the website and download it, but it would be kind of nice if you could just use it from anywhere without having to install it. And so that's the idea here, is making JQ as a service over SSH. So it's basically a dedicated public SSH service with no authentication that will run JQ for you. And that's about it. So again, let me know if chat's working. Say hi, because I had some trouble with chat last time. Wasn't sure if I was getting a working chat pop out. But definitely ask me any questions. This is a great way to get started with Go, get started doing stuff with SSH, maybe doing stuff with Docker, and we're actually going to deploy. And actually, we're going to do the deployment first. So last week we did, we basically prototyped a deployment pipeline for, we built a Hello World SSH server in Go, and then we deployed it to Google Cloud on their container engine, so Kubernetes, Docker, and set up a deployment pipeline so that when we push to master, it would use Circle CI and build an image, push to the Google Cloud registry, and then deploy to Kubernetes. And so I've actually more or less copied a lot of that. We almost had it working in the last video, the last stream. By the end of it, we had it deployed, but the load balancer, which was kind of an extra thing, we didn't get that quite working. And then afterwards, somebody actually submitted a PR, and we figured that out. So based on that learning, kind of copied the files in there and set this up. So Circle CI is already set up, and so you can actually go, use this repository. It'll be around after this video. Use it as reference to learn whatever. Oh, hey, JF. Cool, chat's working. Did you want to go by JF? That's anyway. So the GitHub repository is here. We're going to be pushing to it. There's already some code there. It's not really fully working yet. So we're going to basically do another Hello World and deploy that. And then to make sure this deployment pipeline is working, that way we can kind of build it locally, and then it'll be ready to deploy it, and people can actually try it out while we're working on it. So I think that's about it. Also, I mentioned using a component framework, and so I said that we kind of talk about both of those, and I don't think that there's going to be time for that. So but I still want to use that for this project. So I think I'm going to split this in two. So this will be kind of the first prototype pass at getting this working, or actually build it and have it working and deploy it and it's usable. And then next week we'll kind of revisit it and kind of refactor it into this component. Oh, Joby1, yeah, how's it going? So we'll refactor it, and then using the component framework and maybe even run it in production. I actually want to run this as jq.command.io. So you can basically, instead of doing jq, you won't have it installed, you'll be able to do jq.command.io. And that, I think this would work. We might have to do this. We'll see how it goes. But this is kind of the goal. But we'll do that next week. This week we'll be putting in an IP address here, whatever the load balancer gives us. And of course you could, if you use command.io, you've probably already done something like this and played with making JQ as a command. I wanted to do this project because command.io is really made for like private commands, custom commands for your organization, for your stuff. And so doing kind of public commands on command.io doesn't really work. And so I decided, well, there's not too many commands that you really want to make public. There's a couple of handful of things that would be nice. JQ is one of them. And so that's the idea with this project. So if you haven't seen command.io, you can also check that out and request access to this thing. It'll basically let you do any kind of command line tool as a service over SSH, and you can do access it via HTTP and a bunch of other cool stuff that we'll actually hopefully be building live on these streams, or at least prototype the new functionality. So anyway, this is a sort of separate project, and maybe it'll be a nice way to introduce people to command.io. Okay, so we've got this project open, and before I forget, this is a two-part, hopefully, yeah, we'll be doing this in two parts, so in case you miss the notification for the next one, it'd be a good idea to subscribe to my YouTube channel, and then get notifications of all kinds of other things that I stream. Okay, so what we're looking at here is the stuff that was copied over from the project that we did last week. And this is already set up, this key here. To sort of summarize, we have some Docker files that we need to change because they're made for running our demo Go application. But the main thing is this Circle CI configuration, which was designed to try and be really, really efficient, so that the builds happen really fast. So it installs some of the tools. And it's not just building, because if it was just building, it'd be pretty easy, but we actually want to interact with Google Cloud. We want to push the image to Google Cloud Registry and then actually deploy, and that requires two tools, or a handful of things. We need Docker, we need OpenSSL, we need gcloud, we need kubectl, we'll call it. And let me fix this. And so we basically got that working. Like it took, an hour or two to get all that working before, and so now we can kind of just take advantage of what we learned. So I kind of just replace some of these. Cool. Yep. Okay, so this is the Circle CI config. It's Circle CI runs in a container, and we're basing that container off of the Google Cloud SDK Alpine container, so it's really lightweight. We have to install some things, and then we build our binary. We get the binary out, and then we actually build the container by putting the binary in, the separate containers. I really wanted to, that was one of the things we were trying to do last time, was I wanted to do the multi-stage builds that Docker has natively now. It's something that we've all wanted since the very beginning of Docker, and it's now in there, but Circle CI doesn't support it. So we had to do this. It's sort of the next best thing. We have 2 Docker files. And then our credentials for Google are stored in this gliderlabs.json file. A lot of the time I would put the credential, because it's a big JSON file, I would do base64 encode it and put that in the environment on Circle CI. But it's this huge base64 variable, and so I tried something different this time. Instead, we used OpenSSL to encrypt that key file, put it in version control, and then put the key to decrypt it in the Circle CI environment. So it's kind of a little bit more moving parts, but it just kind of maybe feels a little bit more manageable. Not sure. And then lastly, we run this on Kubernetes. It's actually a really simple configuration. It's simpler than we ended up with at the end of the stream last time, because we didn't need to use the ingress stuff. We just, because it's a TCP service, we just use the load balancer service on Google Cloud, and that will give us a TCP load balancer. And our deployment, defining our pod is really simple, because all we're doing is running this image and listening on this port. That's another thing that I missed. I set the container port to 22, even though it was set up to listen on 2222. Anyway, all that's pretty resolved, so this should work. We just need to write a little program. So we're going to build a, just to make sure that the deployment pipeline is working and that we have something that we can actually deploy. We'll build that and deploy that, and then we'll get into the JQ specific stuff. In theory, this should all go pretty fast. So if anything's too small, definitely let me know. I can make them bigger. So doing kind of the Go file structure here. We're going to call this JQ serve, the binary that we're producing. Let's see. I think that's what I want. And we need main. The first thing I usually do is just do a hello world and then run this, make sure this is working. JQ serve. If you're not familiar with Go and you're like, oh, it's a compiled language, and you're used to being able to just run Python or Node or something, Go run is actually pretty great because it feels like it's interpreted, but it's actually compiling it, and it's so fast that you don't really notice. So a lot of the time I'll do this instead of doing a build and getting a binary, at least to start. And we actually will make an SSH server, and our Hello World SSH server that we used before was actually just from the Glider Labs SSH examples. We'll grab that and do this pretty much the same thing. Look, 16 lines and we have an SSH server. That is the benefit of Glider Labs SSH. Let's see, hello world 2222. Let's actually log something, because before we didn't output anything, so it was kind of hard to tell if it's working or not. Okay, so this is an SSH server. We can actually run this locally like this. And I would probably have to do SSH keygen. Get rid of the host key. This, by the way, is generating a new host key every time it's run. So it's sort of not ideal when you're doing development, but it definitely gets you started pretty quickly. So now we can do SSH localhost. Yeah, port 2222. And we get hello world. It says known host, and at the end of this is connection to localhost closed. It's because we're not providing a command, we're not running it. Alternatively, we could pipe into it, and both of those things would it'll not be allocated because standard in is non-terminal. Does it say that every time? It's kind of interesting. So that actually seems easier to just give an arbitrary command, because it ignores the command and then runs it without allocating a terminal. And that gets rid of the connection to localhost closed. So now we have a hello world service. We should be able to deploy this, although I'll need to double check this Dockerfile stuff. So first we're building it. We're building it in the Golang 19 Alpine image from Docker Hub. And this is just to build it. So we're copying this into source command, JQ serve is our only dependency, and we're not doing any more dependency management. And then our output is JQ serve working directory. Yeah, so it should put it here. So this is a kind of a shortcut. Instead of doing the way a lot of people will do these build containers is they'll do the build and then they do Docker build, and then the binary's in the container, and then the only way to get that binary out is to then start that container or create it without running anything, and then doing Docker CP and copy the file out. It's actually, you can skip that by just having the default command cat out the file. This way, after you do Docker build, you can just do Docker run with --rm and then pipe that to a file and set the execute bit on it. And it's a little bit simpler than the way most people do that. So this should be fine. And then here, we're assuming we're doing this Docker build in the same directory. So we have our binary, JQ serve, and we'll put it in here. And actually, you can see we're doing the execute bit after we've copied it in. We can do that before just as well, but this kind of both makes sure that it's set and makes our CI configuration a little bit simpler. The one thing though, maybe just for preparation, we'll actually install JQ in here. I believe, so we're using Alpine, I believe it is just the JQ package, and so this is what we'll actually run. So in theory, you could do this with OpenSSH server and then configure it to always, when people connect, run the same command. So that's one way to do this. And it wouldn't be that different, because the way OpenSSH works is every time you SSH in, it's always creating a sub-process for your shell or whatever it is you're running. And so in this case, we're doing the same thing. We're not creating a new container or anything like that. We're actually running another process of JQ in the same container. The idea is eventually, over time, we can actually, JQ does have a C API, and so in theory, you could use C bindings, which are actually pretty decent in Go, and just use JQ and run it in process. And so that way we don't have to allocate memory and start up a new process. and stuff like that. So we, in theory, get a little bit of a performance boost, which is particularly useful for running this at scale. Because this is a public endpoint, or it will be a public endpoint with no authentication or anything, that's the ideal. But for now, we're just going to more or less shell out. But we're going to do that from Go so that we have kind of a code base that we can work with and customize more easily. And simpler and more secure. It's actually easier to do this than to get OpenSSH to do what we want because of the simplicity of our SSH library. So we're not going to run that yet, but we are going to install the JQ package just to get it in there. And I'm going to commit this and actually just see what happens. Circle CI is already set up, the cluster is already set up, and so if everything goes well, this should actually just deploy and we'll get a hello world at an IP address that we can all try if we did everything correctly. So let's try that. Yeah, all of this. Pushing to GitHub. So now it's on GitHub. We should be able to go to Circle CI and see what happens. What do we call it? JQ CMD. So it's building it, it's installing Git, it's grabbing Glider Labs SSH, it's doing the build, now it's building the image, seemed to build it all right, now it's pushing it. This shows that our key and everything looks like it's working because I think it's about to push. Yep. So on Google Cloud, and oh, it's connecting. And it's waiting for it to run. Wow, look at that. Very first try. Some 5 seconds. Well, more than 5 seconds. Whatever it was. Less than a minute. And in theory, it's running somewhere. So our local kubectl is set up. Running the proxy. This is how you connect to the dashboard. So when it says localhost, this is actually in Google Cloud. It says that they're running. We can look at the logs and make sure that it's serving. We got that. And we have services, and that's still setting up. So I imagine what it's doing is allocating a load balancer, and so pretty soon we'll have an external endpoint, and we'll be able to SSH to it, and it'll say hello world. And then we can get to the JQ stuff. This is going pretty smoothly, unlike last time. If there's any questions so far, let me know. One of the things kind of is nice is that we're not doing any authentication. By default, our SSH service does not, if you just kind of run SSH listen and serve with this handler, it actually will accept any connection. It will not do any kind of password or key-based authentication, just allows all connections to come in, which is actually what we want for this application. So that's really nice. We don't have to do anything special. I don't know why this app isn't reload. Kubernetes controller, API, whatever, does have a way to watch for events, and so you'd think that they could get this dashboard to update when things update. But instead, you can't even click the same thing. You have to go to another page and back, or hit reload. But a lot of the time, for me, it's just simpler to just go to another page and go back. It's kind of annoying clicking the same thing doesn't actually reload the page. We can, I guess, start thinking about running a JQ. So we are going to be shelling out Golang, and again for this one, so we're actually from Go. When you connect and your session starts, it's actually going to open up a sub process with the OS exec package, run JQ. And because JQ is stateless, it's like you give it input and then it gives you output. So we're just running it to, process whatever thing, which is actually, we'll have to remember to wire up standard in. Otherwise, this will be kind of useless. We could see how this is going. Okay. They're kind of assume that you're doing HTTP, which is kind of obnoxious. Make it hard to grab just the IP. But it should be on 22. Yes. Hello world. Wait. Oh. Okay, so we have to think about this because we're actually deploying it to a cluster, and we did a replica set of 2. So there's actually 2 instances of it, but we didn't configure it with any kind of host key. And so because of that, it's going to start up and generate a host key. So if we get 1, you're going to get 1 host key, and then you write that to your known host, and you connect to it again. It hits the other one. So we actually have to fix this, which is a very common thing. Pretty much never going to deploy anything to production that is using the default host key generation. So let's see, there's a couple ways we can do this. So we can generate a host key and put it in Kubernetes as configuration, and then mount it into the pod, which is probably the easiest thing, because then we're just reading from a file, which is really easy to do here. We want to generate it, and then we don't want to version it. Actually, I don't think, maybe we don't care. I mean, in theory, if somebody else could pretend to be you. So yeah, we don't want to make that public. So that's when it's annoying, is when you can't put stuff in version control. Let's get it working locally with some kind of private key. I think we can, I'll use my private key as the host key, and we'll test it locally. So actually go and see with the docs, go doc, SSH, how do you set up a key? Add host key. I think there's a helper. Public key, public post. Wrap up. Here we go. These are the options. Host key file. So here's what this looks like to get it to start. And this is usually the first thing. Oh, I think we actually just want to do this. So I'm going to hard code this. Users program.sh ID. So I'm actually using my key that you normally use to connect the key. You can use it for the host key. This is just local, so it doesn't matter. So in theory, I can run this, connect to it. First, I'll clear the current host key, and then connect to it, adds it to known hosts. And then if we close it and start it again, it runs without having another host key. So now we need to generate a host key and put that on Kubernetes. I'm always thinking about how to operationalize things and make things automated. In this case, it might actually just be easiest to manually create a config map. Stopped the proxy. Manually create a config map and let me paste in that key. Because I don't want to version it. I keep thinking, is there a better way? Yeah, managing secrets, it's like that's already a hassle, and then even when you have the right way operationally do it, whether it's Kubernetes, config maps, or secrets or whatever, in theory it's a secret. I don't think it actually, I guess it's probably best to make it a secret. So we store it as a secret, and then we can mount it in as a file. That's fine. But then what if we tear down the cluster and create again? We had to manually create that thing. So maybe here's what I'll do. A lot of the time, wipe out your known host entry when I'm building new host with a reused name. Yeah. Which is, but if we're deploying it, so one of the patterns that I do is creating a local directory that is ignored, and this way I can put any kind of files that I don't want to version that are really just specific to me, like a to-do or development keys or whatever. I can kind of have them in here, and they're not versioned. Because what I want to do is create a manifest for a Kubernetes secret, which is kind of obnoxious because I think I have to base64 encode it when you put it in. I forget. Is that how you use Kubernetes? Kubernetes secrets. Yeah. Oh, I could do create secret. That'd be one way. What does this do? Okay, so let's see what it will create. Generic has a name, I'm assuming. From file. Okay, so that's the name, and then there's going to be a key. I'm assuming it uses the file name. So then there's this secret, and then there's the data. Yep, and that's the key. Okay, so we could do that. And I could pretty easily do that here, and that would even allow me to not show the key. So if I were to generate a new host key, key gen, we generate a host key. F or file where you want to put it. I guess it'll just and then type. Okay. RSA. Yeah. So I'll put it in local. Yep. And then it's the private key that we want to put up there. Almost. Now I can see it and type. Again, kubectl is configured and pointed to Google Cloud, so that's kind of nice. What do we call this? JQ. The way I do stuff with Kubernetes is I pretty much name all related resources the same thing because they can have the same name if they're different resources. So just kind of keeping things tidy and then allowing you to use convention IAM. Just always name all the different things related to it the same thing. From file, local, oops. So this is going to make the key. Oh, interesting. I wonder if it's going to use, should just use, we'll see what it does. And not pub. Okay. Cool, host key. So now we just need to, I'm going to look at command IO and because that has how it mounts and all that good stuff. So we're going to do mount basically this exact same thing. So this is volumes under spec. Sure, we'll call it host key. The secret name, call it JQ, and the items. The key is host key, right? Host key. Path is host key. Okay, how does this get mapped? So we have that, and then volume mounts, name host key. Okay, so I guess key and then path is the file name that it would be. So we just put this in here under a container. Sure, it's sort of that. Host key. So maybe I'll just name this all host key. So now we should have mounted in temp host key. And so we could, so now we have to load this. So I'll hard code it for now because this is a prototype and we have a deployment cycle, and so we can just deploy it and use the hard coded thing. And then next week, when we have the component stuff, that gets into like configuration and all this stuff. It's really cool. In the meantime, though, yep, temp host key. Hopefully that works, and hopefully that works. Host key secret mount. Descriptive enough, hopefully. So, yeah. In theory, when you apply a file, I don't know the exact behavior for Kubernetes when you apply a file that apply a manifest for a resource that already exists. In theory, it should recreate them, but I hear it doesn't always. So I guess we'll just see what happens. Master. Pushing. So this is build 3. And so the image it should be running is build 3. Looks like it's closed in the old one. got the new one. It's running latest, I guess. So assume that's build 3. And does it give you mount information? Does it say that it's mounting stuff here? Pulled, assigned. I guess that would be the. This is a pod. It seems to be okay. I'm surprised this doesn't actually tell you if it mounted stuff. But I guess we can always look at this definition and see that we have volumes mounted. Looks like that's there. So well, just try it. Which we probably want to remove that for now, and then get the new key. Do it again. Cool. So both are running. They're both using the same host key. So we solved that problem. Now we just need to run JQ. And again, as this proof of concept, this should be pretty straightforward. And we kind of already did the complicated stuff of getting a deployment pipeline and getting it running in production. It's already running in production, and it's not even working yet. It's sort of like production-driven development. I don't know. Oh, hey, Travis, I haven't talked to you in a while. What is that? Kubectl exec pod ls. Oh, that will actually, yeah, do an exec in the pod. That, yeah, thank you. I guess because of the delay, I already figured it out, but that's good to know. I always forget about that. So I guess we can actually just write the code to actually run this, run JQ. And in theory, JQ is in there. Actually, we'll do kubectl exec JQ to make sure that it's in that container. So we need the pod name, right? You weren't leaving anything out, were you? In theory, we can just do JQ. Oh, okay. Exec flag needs an argument. Oh, is it? It's interpreting that as a unknown option V. JQ help. Well, it's running JQ. Looks like. Well, there's JQ help. So JQ's in the container. We just have to use it from SSH. Again, since there's people chatting I didn't hear about before, we are going to do the simple thing and just shell out, and later on next week we'll do kind of the nice production version of this, and then it's still going to shell out, but then later on in the future, because it's open source and PRs to master will get deployed, and I do expect to run this, then somebody else can basically do a in-process version of JQ using the JQC library, which is an unstable API, but people are using it. And basically just recreating, we're doing the same thing. We're not doing any of the kind of internal, like messing with data types and stuff. We're actually just saying like, hey, top level run JQ. Okay, so we actually have a little bit of work to do. It's not just shelling out. We're going to wire up standard in and stuff. But that's not a big deal. Now, I'm very tempted to not do any kind of testing and just to deploy it. No local testing, and just deploy it, because I'm not going to get this right. First, so let's actually just run. Let's just get like the output and write that out. We can do more or less this. instead of hello world. So where would you think JQ be? In theory, we need to, well, the path, let's see. I don't know if path is going to be set. I mean, it works from here, but I don't know if it's actually running it in a shell. No, we'll try it. JQ help. Output. Ugh. Okay. And we don't want log fatal. Actually, we don't really want any of this. We want to. What is this error? Is it going to be like, hey, it didn't run? Oh, but it's going to give us standard error. So either way, we want to write this standard error to the session. So really, it's a matter of whether we're going to do a non-zero exit code, I guess. So we could actually just do that, not care what this error is, and just do exit 1. And if you don't specify an exit after the session handler is run, it'll do exit 0. So we can do this. And then we want to write at some bytes, right? So we can actually just write some bytes. And there we can, who cares? I'll just do that. And we'll commit this and deploy it. Okay, now, see, it's like the good old days. It's it's like PHP development. Except I don't know if we used Git then. We just used FTP and copied files. But this is a little bit slower, right? But because we did try and make it as fast as we could, and if I spend some more time, we could probably get this build to be a little bit faster. But you know, about a minute, it's pretty. I mean, there's plenty of people with a much longer. CI cycle, let alone deploy cycle. So we're doing okay. But yeah, it would be better to get this faster. In theory, we could replace Circle CI with Command IO. Except we won't get the output like this, and so that's kind of as it is right now, we wouldn't be able to get the kind of feedback, this kind of easy feedback on whether this stuff is working. Okay, so it's deployed. We can see if it's working. Still hello world. Rolling out some containers. Oh man, fine. Let's check, see what's going on. Ugh. That's kind of, I'll just make another thing and just run the proxy. Yeah. Pods. Oh. FTP, yeah, just SSH in and like Vim files. Yeah, you can kind of do that. I mean, that's basically what glitch is, right? So I think the problem is our manifest didn't change because we're always using latest. If we had dynamically changed this to say build whatever, it would roll a new thing. So that's something that I didn't run into before setting up the pipeline because we didn't really use it extensively. I guess what I could do is change it from here until we fix that problem. So this is build 4. So I'll just edit this deployment, and then that should roll. Wait, yep, okay, I can edit it. Build 4? Yes, right? So now it should be doing a new replica set. What is it? Replica set, right? It's not replication controllers. Why are these even around anymore? Okay. Okay, that's not what we want. Oh, cool. It's JQ's help. So we're almost there. We just have to take any arguments that we have from SSH, pass them to JQ, and attach standard in and have a standard out of. See, right now we're doing combine output, and so we're getting a bunch of bytes kind of buffered. Ideally, though, we'd stream it out, so we'll do all that now. We didn't even need to test it locally. It worked. So let's see what we actually command. The way this API works is the first command name and then arguments, which is perfect because S, which I don't know why I did this, session is I like a little bit more session. We can just do command ... right? And that should do it. Yeah. So command on session is whatever command that was run, if there was any. So it's already a split string, so a slice of arguments. And it's called command because it's assuming this is the command that you want to run. But here we're just saying we're using them as arguments to JQ. And so we did arguments. Now we want to do the standard in and standard out, which, let's see, session gives us what? Oh, I guess it's just read. So actually we do IO copy. That's kind of nice. Good thing I designed it that way, right? No, we can't do IO copy. Because we need, well, maybe we can. I think we have to set up some pipes here. So we set up some pipes. We get a write closer. Okay, so we'll set up some pipes and then we can do IO copy. So that does a read from the session and then writes into the standard pipe. Yep. So now I guess we'll have to start doing some writing to the with whatever the error is. Fprint line error. And then exit. We'll do one, I guess, return. So that's how we'll handle errors. We also will need a standard out pipe, right? I guess, and standard error. Read closer and standard error pipe. Yeah, that's what I remember. Usually when I do this, I can just, well, actually, could we do that? I usually don't use pipes. I'll usually just take the command structure and then set standard in. So we have a reader. So we actually set this to session. Set all these to session. At the that's what I usually do instead of this pipe nonsense because it's a little bit simpler. The let's see. Oh yeah, see, it's already. Well, I mean, I just got your message after I decided to not do this, but good reminder. The reminder was I needed to do this. Thank you. But I think we can just do this. Why does this feel different than the way I usually do this? I don't know, I guess I'll just do it and see what happens. This is, I need standard error. Yeah. And then we run it, right? Which I guess we can do run instead of start and wait. Yeah. Let's do that. This is now sesh. How does this look? Do you think this will work? I don't know why this doesn't look right. This is how I normally do it. I just don't remember what's different. And what is with this coloring? In theory, it builds, right? It's building. That's fine. Is it building? Adam usually tells me. All right, well, let's just do this. Let's just deploy this. Maybe wired up. This is a prototype. We don't have to worry about commit messages. Again, though, like I mentioned, I don't have my commit voice. You know, what is the standard way? Best practices. There's a lot of different ones. I haven't quite figured it out for my projects. So in the meantime, there's a lot of these really shitty conversational commit messages. Oh, no, we want to see the next build. And we might have this done in time. If I was a little faster, maybe this will work. Let's try and get this done in an hour. And then because it's going to say latest instead of build 4, it should roll these pods. In fact, they should already, yep. So, help. This is, so we might have to do dash between the arguments because it's going to show the SSH help. If I do this though, we're not closing stuff. It's just going to hold this open. But it should work. If I were to do this, pipe it in here, and because it's not dashes, you can just do like name. Oh, it worked. It's not coloring it because I guess terminal stuff didn't allocate a terminal, so it's not colored. And of course, we try and do any of the options here, it's gonna think it's an SSH option, so we have to do this, and that's kind of weird. Let's see, I don't know how I feel about that. But also, that seems to close. Why is it? Why is that working? And then because right, duh. It's like if you're not providing standard in, this is gonna wait for some input, and we didn't have any, right? So we do this. Oh shit. Because of the terminal. Force no. I think we can do this, and then it's going to expect some input. We could actually write name equals hello, and it would echo out hello. It's actually streaming. Does JQ normally work this way? We can do, so it's always just going to filter what if there's new objects, or is it just done? Name hello again. No, okay, so it's just done. So, I guess the idea is, what do we want to close? I guess there's nothing to do in this case. What's the close thing? I guess we could do EOF. Oh, that worked. Let's try that again. Name foo. Name. Interesting. I don't know. How does JQ, if you do JQ, because it's assuming it's a, because it can detect if it's a terminal, I guess. Okay, well, okay. It seems to be working good enough for a prototype, right? So we'll say that's done. We've already, it's deployed. I don't know if anybody's tried it, but it would be cool if somebody else tried it. You should be able to take some JSON and pipe it into SSH 35.202.99.170 and then provide it a JQ pattern filter, and get something out. So yeah, that worked out pretty well. I'm going to leave this running. I don't know for how long, maybe until next week. But yeah, this definitely needs to be cleaned up. This is kind of interesting, the whole thing that we, like, an hour long, JQ as a service, and we did it in 24 lines. And of course, it was all the infrastructure and stuff like this that took a long time to get set up. But luckily, we figured out most of that before. This is pretty cool. Yeah, I'm sure there's a better version of this. If because this is on GitHub, if any of you want to play with this and find anything out, want to submit PRs or whatever, that would be really great. And then next week, we can if anything that came up, we can integrate those, and then also start putting in this building this with the component framework that'll give us configuration, some other nice logging infrastructure and stuff like that, and then we'll probably have time to do like some stress testing, spin this up on a couple of nodes. And there's no, unfortunately, most load generating tools are made for HTTP, but we could create an SSH client that's exposed as an HTTP server and then run that as a proxy from where you run the load tester. So we could try that. It'd probably be good enough, and then we get sort of an HTTP representation of using this SSH service. That'd probably work. But we can do that next week. So anyway, I'm pretty happy with this. Hope you guys had fun. Subscribe to the YouTube channel, and join me next week for this. And let me know if you want to do, if you have other ideas for projects and stuff. I have tons of stuff. Most of these projects are not sort of like, I mean, they're kind of experimental, but they're not just academic. Most of these have some kind of purpose. Like this, eventually I want to run as a service. It's actually a public endpoint, jq.command.io, as a way to sort of help market command.io. And a lot of the other stuff that we're kind of building up from the bottom are going to go into kind of bigger projects, and hopefully I'll stream a lot of those as well. In fact, I might even, because the component framework that I wanted to use, I'm in the middle of rewriting it, so that's part of the reason why I didn't use it today. I actually have an older version. It's what Command.io has done, but I've been using it for about a year, and it's based on kind of more kind of research, and is definitely super refined now, and is really, really cool. And it brings like reusable, extensible components to Go in a really, really lightweight way. It makes it really great to make kind of loosely coupled applications and sort of micro frameworks and stuff like that. So sounds like a lot of stuff to put into next week. Anyway, well, I'll figure it out. So that's it for today. Thanks everybody for watching.